today?
Yes.
Okay. Don't have them yet. Only one I have is the one you sent me yesterday. In fact, I don't have that anymore because I just closed it out. Hold on, let me see if I can find that. Justin Allen. That's the one that I just had open. We haven't done this yet, I know that.
Which one?
The one we're looking at.
Hold on a second.
You can see my screen, I gather.
Yeah.
Okay. We definitely have not done this page, anything on it. So we can begin here if you want. But you know best as to what you need to work on and what you don't. So I would prefer if you direct me.
Okay. I got a couple different ones because we were learning Kramer's law, I think it was. What? Like Kramer's law?
Oh, it's just I'd have to go look it up. I don't know matrices that well right off the top of my head. Just because when people, I don't get matrices every year. I get it once every 2 years. A student like yourself who goes to Evelyn wants to do Kramer's law and augmented matrices and all of that. And that's fine, but I can't do it off the top of my head. I would have to go do a little research.
Okay, well, I have a different one also that we learned recently.
All right. Let's see. You still have more appointments before your exam, is that right?
I think I have one tomorrow.
Okay. Let's do the matrices that day. I will have time to prepare in the morning, and I'll know how to do Kramer's law and any other matrix problems you have.
Gotcha.
So for today, let's do anything that we have available, which is this, or whatever you send me, except I haven't gotten it yet.
Okay. And just, by the way, I apologize. I have the physics tutor coming over at 8 o'clock. So
no problem. I have Dylan at 8 o'clock, so I got to go by 8 also.
Okay. I think what my mom said was to be off by 7:55 or so.
Whenever you need to quit, you just holler.
Okay.
I can go at any point that you say I need to quit.
Okay. Gotcha.
Okay. Still don't have any email. Now, last time we went through this, I did get all your emails, but they came in, 20 minutes after you sent them.
Yeah.
So we don't want to wait 20 minutes, so what would you like to do while we're waiting? We can work on this one page that we've never worked on, or you can verbalize problems, whatever you'd like.
I think I'll verbalize these couple.
Okay, let me close these out and open up my other page that lets me write stuff. All right. Shoot. Oh, and this program's changed also. Go ahead.
So this problem says a 7-sided regular polygon is inscribed in a circle whose radius is 5 inches. Find the area of the polygon to the nearest square inch.
Seven-sided regular polygon? How would you draw a seven-sided regular polygon?
I do not know.
Yeah, that's not the easiest thing to do. Well, let's see. We can figure out what each angle would be. That'll make it easier. Hold on. That's 1, 2, 3, 4, 5, 6, 7. We'll say that that's it. 1, 2, 3, 4, 5, 6, 7.
Okay.
Now, it's inscribed inside of a circle?
Yes.
Which means this, whose radius is 5.
Yeah.
That has to be 5, as does that, as does that, as does that, so forth and so on. So what we end up with is 7 triangles. What do they want? The area of the 7-sided polygon?
Yeah.
What's the general formula for the area of a polygon?
I don't know.
It's 1/2 the apothem. Man, nothing's working. Can't even get my eraser to work. So the area of a polygon is 1/2 the apothem times the number of sides times the side length. That is also perimeter. So it's got 2 equations. It's 1/2 the apothem times the perimeter, or 1/2 A, the apothem, times the number of sides times the side length.
Yeah.
So what we need is the apothem. We need that distance right there.
Gotcha.
I think we'll be able to figure out the side length. What we really need is that angle. Let's draw one of these triangles that I've put in this thing. What's the angle at the top?
Angle at the top. 6 degrees.
It's 360 divided by what?
7.
What's that number?
I forgot my calculator. Can I go run and grab it?
Go get it. You always need your calculator, Justin.
You said 360 divided by 7?
What is it?
Wait, you said 360 divided by 7, right?
Yes.
51.43.
Huh. Unbelievable. I say unbelievable because why would they make this problem harder by introducing fractions like that? Now, this is an isosceles triangle, right?
Yeah.
So if I drop a vertical, I not only create a right angle, but I bisect that angle. So tell me what that angle is.
It's 51.43 divided by 2, right?
Yep.
Which would be 25.7.
Okay. Now notice that we can solve for this side. I'll call it A. No, I won't call it A. I want to call the vertical A because the vertical is the apothem. In other words, that's the apothem. I'll call that x. So we're going to need both, because I'm going to need the side length, which is this length from here to here, and I'm going to need the apothem, which is a. So give me a couple of trig functions that will let me solve for each one. Always start with the trig function and the angle, and then everything else follows.
Sine 25.715
Equals what?
x over 5.
Which means x is equal to 5 times that. Come up with that number.
Alright, so we have, what is it, 5 sine 0.85.
Make sure you're in degrees.
2.75.
So what's the base of this triangle equal to?
Wait, hold on a second.
In other words, x was only from there to there. That's not the side length of this object. The side length is 2x. So the base of the triangle is what? In fact, let's call it s, because in the formula it's s.
Yeah. Oh, hold on a second. Sorry, did you say make sure I was in degrees?
Yep.
Yes, I accidentally had it in radians, so the actual answer in degrees is 2.17.
Okay. What's the side length equal to?
Side length is the 2.17.
No, that's this distance here. In other words, the only triangle we were looking at was that one. Right? We took this big angle and divided it in half because we dropped a vertical. So now we're just looking at this right triangle, and we're trying to solve that right triangle. And that's always the way these problems unfold, is you end up with the big triangle that you split in half. So if x is 2.17, what's the distance between here and here? When you have an isosceles triangle and you drop a vertical, what does it do to the base?
Wait, you have an isosceles triangle. What is the vertical?
If you have an isosceles triangle like we do here, and I drop a vertical, what does it do to the base?
Makes the base shorter.
Splits it in half.
Yeah.
Okay, so if x is 2.17, what's the whole base?
Multiply that by 2.
Do it. Okay, so that's the distance of the base of the triangle, which is this s right there. Now we still need the apothem. Give me another trig function that's going to let us solve for the apothem. We've got an s of 4.34, but we need an apothem. We know what n is. N is 7. What trig function lets us solve for a?
Is that the Pythagorean theorem?
Nah, don't use it. Use a trig function.
Is it tan? Wait.
Well, the problem with using tan is that you're going to end up using this number 4.34, which is actually an approximation. It's not an exact figure. So let's not use tan. How about cosine? what's the cosine of 25.715 going to equal?
Cosine of 25. That would equal 0.9.
No. Give me the equation. I'm not interested in what the number is. I'm interested in SOHCAHTOA. What is the cosine of 25.715 equal to?
It's equal to
the adjacent side over the hypotenuse, right?
yeah.
What's the adjacent side?
A over 5.
You got it. Now that allows us to solve for A. In other words, the apothem is going to be 5 times cosine of 25 point whatever that angle is. So what's the apothem? It's whatever that number is.
Yeah, exactly.
What is it?
You want me to find it?
Yep.
That would be 4.8.
4 point what?
50.
Now, to get the area of that object, we got everything we need. We know that it is 7 sides. So all we need to do is plug it in. So the area equals 1/2 the apothem, which is 4.5, times the number of sides, which is 7, times the side length, which is 4.34. Whatever that number is your area.
Gotcha.
Now notice what we had to do here. We had to do a lot of stuff. But you have to do every single thing that we did, you're going to have to do if they give you a 9-sided figure or an 8-sided figure or a 5-sided figure. They're all going to be the same. You use that formula, but you have to be able to figure out the apothem and the side length. This being the side length, this being the apothem. And the only way to do that is to figure out the central angle for each of these 7 triangles, the big triangles. That's that angle. That's the one you figured out to be 51 point. For some reason they felt a need to make us work with decimals. They don't quite get that. In other words, is there a problem with making this a 6-sided figure and then we'll have nice round numbers that we'll be able to do things with? It's one point of disagreement I have with the education system, is that they make these problems overly necessarily difficult by using 7 sides instead of 8 or 6. If they used 8 or 6, this central angle would have come out to be a round number.
Yeah.
And to me, it would make the education process better, because all we do is get bogged down with these numbers that have 3 decimal points after them. All right. So let's see, let me check my emails and see if I got anything. Nothing. Okay, you got another one you can verbalize?
Yeah.
Because I'm not quite sure what's going on. This same thing happened though the other day with you and me. So we'll just chalk it up to whatever. It's not only you, it's happening to other people also. But not everybody. I still think it's related to the fact that you're in King Carl Valley Ranch. I think they have a limited amount of bandwidth, And King Carl Ranch keeps growing and they haven't expanded their router. So everybody gradually with time gets a smaller and smaller amount of bandwidth, and low bandwidth means the audio goes out and things like that happen.
Gotcha.
I think. That's my theory. I don't know for sure though. And also that it delays emails. I have no other explanation as to why both yours and Dylan's emails take 20 minutes to get to me. Nobody else's emails take that long to get to me. So it's weird.
It's kind of weird.
What else you got that you can verbalize?
I have the perimeter of a regular pentagon is 30 meters.
Okay.
The area of the polygon is square meters.
Okay.
Remember,
Remember,
pentagon, doesn't that mean that all the sides are the same?
yeah, if it's regular, it does. And incidentally, these formulas for area depend on it being regular. In other words, the formula that I gave you, A equal 1/2 times Apothem times the side length times the number of sides, that's only true for regular polygons. It's not true for odd-shaped polygons.
Gotcha.
Okay? Now, notice there were two formulas. One was that, and the other one is this, because the side length times the number of sides is the perimeter, right?
Mm-hmm.
So they're only giving us the perimeter. They're not giving us the side length. Did they tell us how many sides it was? I don't think so. What's it say? Read the problem again.
The perimeter of a regular pentagon is
Okay.
30 meters.
Pentagon means 5-sided.
Yes.
All right. So we can figure out everything we need, and we can use either formula that we want. Okay. So, again, let's draw something rudimentary. Doesn't have to be exact. That's not a regular pentagon. That's just a pentagon, but I don't know how to draw a regular pentagon. The key is to be able to figure out the central angle of each of these triangles. What's that angle? I do hear all of that. That's coming through our phone, I think. You have the GoToMeeting set on telephone, not computer audio? Because if you have your telephone set on, if you have your GoToMeeting set on computer audio, a lot of times there's feedback. And if we're on the telephone, you don't want that. You want to go back up here and set the label on use telephone, not computer audio. Kidding me. I lost audio with you? I lost the phone call? Justin, can you hear me?
I can hear you.
You can hear me?
Yeah.
Okay, because I lost audio for a full minute. I was about to hang up and call you back. All right.
That's kind of weird.
What's the central angle of this pentagon?
It would be 360 divided by 5, right?
72. At least this one they give us a round number. Okay? Now, you see the triangle that I'm pointing at? I'm going to draw it separately. This is never a bad idea because now we can analyze it using a trig. What's that angle of this triangle on the left? This one here. What's that angle at the top?
Angle on the top is 36 degrees.
Now, we need the apothem apothem, what's the side length? What's that length down there? If it's got a perimeter of 30 and it's 5-sided.
That means it's 6.
Okay, that makes that 3. Now, we know that angle, the small one, and we know that side. Can you calculate the apothem? Give me a trig function that allows you to solve for A.
Sine, tangent 36 degrees equals 3 over A.
Solve that for A. What's A equal?
A equals, 3 divided by tangent, 36, right?
Uh-huh. What's that number?
Hold on a second. Something's weird. Divided by tan, 36. That is 4.13.
So A equals 4.13.
Yeah.
Now, notice this formula here that's based on perimeter. It's a little more succinct, but it's the same formula. In other words, the side length times the number of sides is the perimeter. But they gave us the perimeter, so the only thing we need to plug in there is the apothem, which is 4.13, times the perimeter, which is 30.
Yeah.
There's your area.
1.95.
How much?
61.95.
Okay, that makes sense.
Square meters.
Correct. Checking my email again. Nothing from you. What else you got that you can verbalize? I don't think we should spend too much time on any more of those, because each one of them is long, but once you figure out how to do one of them, you should know how to do all of them.
Yeah, true.
Do you get a cheat sheet at all when you take your exam, or do you have to memorize all this stuff? Okay, we'll memorize that area formula for a regular polygon. Area is 1/2 the apothem times the side length times the number of sides.
Yeah.
That's a big one you're going to need. Even with that formula, it still requires a lot of, you have to figure out the central angle, and then half the central angle, and then which trig functions allow you to solve for the apothem and the side length and all of that stuff.
Yeah. Yeah. Okay, how about, I got a different one for you I can revise.
Okay.
So, it says, the wheels, yes, the wheels on Danny's Bobcat had a diameter of 26 inches. If he was traveling at 12 miles per hour, what was the angular velocity of the wheels in radians per minute?
All right. Hold on a second. I always have to look this up, just because I just don't remember. This is a common problem, and the reason I always look it up is because they always have one example problem like this, and you kind of have to remember it. And here it is. So, let's MPH is equal. In other words, miles per hour, the linear speed is equal to the angular velocity times 60 minutes per 1 hour times 2 pi radians per 1 revolution times 13 inches per radian. You know where I'm getting that from?
Yes.
Times 1 foot per inch, per 12 inches, excuse me.
Yeah.
Times 1 mile per 5280 feet. Now, if angular velocity is in x revolutions per minute, does all the units cancel, leaving us with miles per hour? We want to write this as miles per hour. So let's see, revolutions cancel with that. Minutes cancel with this is revolutions, this is, excuse me, let me rewrite this just so it's clear. This is x revolutions per minute.
Yes.
That's what they want their answer in? X revolutions per minute? Or do they say?
Radians per minute.
What's that?
Per minute.
Revs per minute?
Radians.
Angular velocity is always in revolutions per minute. So let's solve it for revolutions per minute, and then we can go back and figure out what it is in radians. The reason it's important to leave it as revolutions per minute is because our primary task here is to make sure that everything cancels except miles per hour. Okay, that rev cancels with that rev. That minute cancels with those minutes. This radian cancels with that radian. This feet cancels with this feet. This inches cancels with that inches. And what am I left with? Miles per hour.
Yes.
So, all I got to do is solve for x, and it will be in miles per hour. Well, x is the result of all of these numbers. In other words, it's 60 times 2 pi times 13 divided by 12 divided by 5280.
Yeah, I have 0.08 miles per hour.
You have 0.08 miles per hour?
Yeah.
That doesn't sound correct. You did that, you did 60 times 2 pi times 13 and divided it all by 12 times 5280?
Yes, sir.
Alright, we'll assume that that is the right answer. 0.8 miles per hour. Read the problem again. I'm having a hard time believing they want the answer in radians per inches.
Okay. The wheel on Danny's Bobcat had a diameter of inches. If he was traveling at 12 miles per hour, what was the angular velocity of the wheels in radians per minute?
Okay. So, on the other side of the equation is 12. In other words, let's rewrite this equation a little bit. Here's what we have. We've got 12 miles per hour equals x revs per minute times 60 minutes per hour times 2 pi radians per revolution. You understand that, right?
Yes.
Times 13 inches per radian. A radian is always equal to the radius. The radius is 13 inches here. So it's 13 inches per radians times 1 foot per 12 inches times 1 mile per 5280 feet.
Yeah.
So revs cancel, minutes cancel, feet cancel, radians cancel, and end up with miles per hour. Did inches cancel? Inches cancel. And I get, here's what I actually get. 12 equals x times 60 times 2 pi times 13 divided by 12 times 5280, and you got to solve this equation for x.
Yeah.
It's not quite what we did before. In other words, now you got to multiply the, so the answer is going to be this: 12 times 5280 divided by 60 times 2 pi times 13. That's what x is, and x is going to be in revolutions per minute. We started off putting it in revolutions per minute, so it stays there. Now tell me what x is.
All right.
155.14 revolutions per minute.
Yeah.
12 miles per hour is awfully slow for that fast of an angular velocity. Nonetheless, that's going to be our answer. Now, read the last part of that problem again. After the 12 miles per hour, they want to know what the angular velocity is and what else? And what?
In radians per minute.
Radians per minute.
Yeah.
So this factor right here so if I divide this answer okay, let me see if I can get a handle on this before you have to run. I know you got to go quick. So what I've got is the following. 12 miles per hour, assuming we don't have any mistakes, which I'm not sure about because this answer doesn't make a lot of sense to me. 12 miles per hour equals 155 revolutions per minute.
Yeah.
Well, I've got 2 pi radians per 1 revolution. So if I take this answer, multiply it by 2 pi, I'll have radians per minute. That's all I got to do.
You think that's reasonable?
I have no idea. To be honest with you, there's so much arithmetic that we did that I'm not doing it with you on a calculator, so I don't know. But the units are right. In other words, we came up with revolutions per minute, and converting that to radians per minute is not that hard. You just multiply it by 2 pi radians per revolution. Revolutions go away, you end up with radians per minute. So it's 155.14 times 2 pi. What is that?
Other than, okay. $974.77.
That would be in radians per minute.
Yeah.
Because every single revolution is 2 pi radians. So once you get revolutions per minute, converting it to radians per minute is relatively straightforward.
Gotcha.
Still seems to me that those wheels, maybe that's right. I mean, if you think about a car going 60 miles an hour, how many times is that wheel spinning per minute? Probably about 1,000 times. If you think that it probably spins more than once every second. So this could be a reasonable answer.
Okay, good.
I don't know. The only way, you know, if you said, would you stake your life on it, then I would have to go back and do it 2 or 3 times and check my math each time. I don't have a good feel for the 3 things that are always the variables are the miles per hour that the car is going, the angular velocity that the wheels are spinning in revolutions per minute, and the diameter of the wheel. Because clearly, if the wheel is bigger, then the radius is bigger, and that increases the miles per hour. In fact, if you double the radius, you're going to double the speed of that car, as long as the angular velocity stays the same.
Gotcha.
And I guess there's nothing else to say about this problem. The key is all of these factors. That factor, that factor, that factor, that factor, that factor, and that factor. There are always 6 factors. Well, they're not always, I guess. They could have given us the speed in feet per minute, in which case we wouldn't need a lot of these conversion factors. So you only need the number of conversion factors that make sense in the context of the problem. They gave us the velocity in miles per hour, so we had to end up with miles per hour.
Yeah.
And once we ended up with a standard angular velocity, then we can convert it to radians per minute, which is probably just as standard. There's maybe nothing standard about revolutions per minute, but whatever the revolutions per minute are, multiply it by 2 pi and you have radians per minute. All right. So I will let you go so you're ready for your next appointment.
All right.
And let's see, when do we have another one?
I think we have one tomorrow.
We have one tomorrow, and you're going to want to do matrices. You're going to want to do just Kramer's rule. Do you know what an augmented matrix is?
I'm sorry?
Have you ever heard the expression an augmented matrix?
No.
All right. If the only thing you have to deal with is Cramer's rule, I'll be ready to deal with Cramer's rule tomorrow.
All right, gotcha.
If it's anything beyond that, then we'll have to work it out as we go. Matrices can be very complicated. In other words, if you could take a course. Linear algebra is basically a college algebra, way beyond algebra. It's all about matrices, but it's a semester course. So there's a lot about matrices to learn. So depending on how much you need to know, I'll be able to help you with Cramer's rule.
All right, sounds good.
All right, Justin. Talk to you tomorrow night at 7.
Sounds good. Thank you.
Bye-bye.
Bye.